essentially, I'm going to be looking at the required change in mindset for industrial revolution in South Africa. As you just heard, that I've got different hats on at the moment, with University of KwaZulu-Natal, in the Smart Lab over there. I'm also the chair for IEEE South Africa for Robotics Automation and Control Systems, and then also for Robotics Association of South Africa. And yeah, essentially, we're trying to sort of get the topic of robotics and the topic of research and multidisciplinary and networking to actually happen within South Africa. Very difficult to get it going and stuff. But yeah, we're going to just be sort of giving you some background and some challenges that we are sort of facing. If we can go to the next slide, please. So fourth industrial revolution, that's what we are talking here about. Fourth industrial revolution is the interaction between humans and machines, and that's all got to do with the Internet of Things. A lot of the things that we have actually heard this last couple of days, and I'm hoping I'm not going to be repeating a lot of the things that has been quite relevant and explained. But we are actually in a fifth industrial revolution because we're interacting with artificial intelligence. As a matter of fact, we're even starting to explore into the sixth industrial revolution, and so it is evolving, and I mean it's evolving all across the world. And we, as researchers in South Africa, have to actually keep up with it, and we have to continue working with the rest of the world. So I'm going to be going through some of the research conducted in the Smart Lab that fits into the industrial revolutions. Not just to give you some examples of maybe a different perspective of what we're involved with and things, but then I will step back out again and sort of look at all the challenges we've got within South Africa and the ways to explore it. And then we will also look at what the future is for the Industrial Revolution in South Africa. I just want to make a note over here, due to my sense of humor. I'm not here to offend anybody. This is more in terms of just to try and make you think of things. And yeah, I hope I'm not, like I said, replicating information that has mentioned before. Next slide, please.
Yeah, they're moving a bit slow.
Okay.
Can I say in the meantime that we can do with some humor at this point in the program?
Well, okay, so if you look on the left side, we've got Pepper Robot, which is quite a nice robot that has come out lately. Humanoid robots have come out as well. I'm finding that a lot of institutions are getting these robots with the vision that they're going to be improving research with them, which is very questionable because I've seen it happen so often that equipment gets purchased and it's a nice to have piece of equipment with the thought of improving technologies or adding to it and stuff, but it's very closed. You know, the code is not made available. It's not an open source platform that you can link to it and integrate with it other things. And so there's a lot of equipment that people have got, which is great if it's for marketing purposes to show what can be done. But it's not really a way to pursue you know, with the research. And I've also found that you know, there's a lot of research happening these days. You know, if you look at these programs on TV of how it's made and stuff, it's recorded in the 1980s, and yet we're busy doing that research at the moment, exactly the same, if not even as good as what they've done in the 1980s. And so I find it often that it is a thing that we are often replicating a lot of work, and it's almost like meaningless research, if I can put it that way. Meaningless in a way that it's been done before, or meaningless that it's not going to be able to get somewhere later on, which is something we need to, you know, look at and sort of overcome. Next slide, please. So this is often like projects that I see happening with undergraduate students, especially. You've got like a Robot wars, again, what's the purpose of it? It's a robot that's destroying another robot. A lot of money goes into it. It looks amazing, but we've just wasted a whole bunch of robots, a whole bunch of money with this robot that's just destroyed, been destroyed by another robot. Or you will see these other robotic systems like washing your hair, putting on lipstick, pick and place sort of robots. But is it actually going to make any difference to the way we're going to be doing things in the future? Look, I'm not a woman. I've never put on lipstick before in my life, but I would think that's something I would want to do myself to make sure it's not done in the wrong way. So the thing is, though, is that we need to think about what the research we are doing, is it going to help people? And especially if you look at a lot of costs that are involved to try and sort of develop this research. Next slide, please. So I often get asked by people about the job security with artificial intelligence. And my response lately is, well, artificial intelligence won't take over your job if your job does not require intelligence. And if you don't get that, then don't worry, your job is safe. So the thing is, though, is that it is a situation artificial intelligence is coming in. It is going to, be involved with all the different activities we are doing with our work and things like that. As a matter of fact, South Africa is the top 7th country in the world that uses ChatGPT, which is amazing. I mean, and a lot of people are saying like, oh yeah, but we shouldn't be using ChatGPT because, it's preventing us from, thinking ourselves, or it might be preventing us from, or be considered as cheating. But let me put out the question over here. What's the difference of you going and asking ChatGPT to do a search on robotics, as an example, and it gives you all the answers over there, and you've got to go and check all those references and see if it's legitimate, compared to you having to do a Google search, find a whole bunch of links over there of information, regarding robotics, and then going to check and verify that data. The difference is that with ChatGPT, you're probably going to find that you're able to find a good source of information. Well, whether it's good or not, you have to evaluate, but you're going to have a handful of information that was generated within 30 seconds, where it might have taken you maybe half a day to get that information. So there is a way for us to make use of this and to improve the way that we perform our research. Next slide, please. The problem that we've got in South Africa, especially with research and development, is everybody's got this thing of it's mine, all mine, and mine, mine, mine. They don't want to share resources. They don't want to share funding. They don't want to collaborate on projects. I mean, I can remember, and I mean, there's people on the panel that were even involved with the projects that we did about 15 years ago in terms of robo soccer platform that had to be built. And I know that, I mean, each institution had its strengths, and yet we didn't get one single robot that was working properly. But if we were able to work together and bring our strengths together, where one institution might have been good with the artificial intelligence, another one might have been good with the mechanical design, another one might have been better with electronic design. And so if we're able to bring that together, we could have had a functional robot working. So it's a big challenge in terms of intellectual property, and everybody wants to have things for themselves. In 2015, I started the Robotics Center of South Africa, which falls under the Robotics Association of South Africa. And yeah, I went all across the country to the different institutions, told everybody we should collaborate and stuff. Everybody agreed, yes, this is a way forward. But when it started actually let's implementing things, it became very difficult. It became almost everybody retracted and said, well, listen here, we don't want to share our ideas or our thoughts, or we don't want to work and co-author papers. We don't want to, maybe apply together for funding. And unfortunately, we are sitting in a situation that, especially when you have to apply for funding, you need to work together to be able to do the application. It centers the application as well. Next slide, please. So again, I'm just going to go through some examples of the smart lab. Yeah, so as mentioned before, the smart lab, it is an acronym, but we stand on a basis that you get a lot of students that are bright, but they can't necessarily do research. And so it's all got to do with having to be smart to be able to do the research. And so I'm going to go through some examples, not mentioning all the examples, there's some of the things that we have to be publishing, but just to give you a bit of an idea of how this industrial revolution has been explored by us in the last few years. Again, just as an examples, and I mean, if you look at the other examples and presentations we've heard the last couple of days, it's even more amazing things that have been developed. But it's again, just to sort of show that there is other avenues that we've been exploring as well. Next slide, please. So we start with aviation. We did research a few years ago where we had an artificial intelligence system that we could implement onto as an autonomous system for any aircraft. And because each aircraft has got different specifications and parameters and things like that, we were able to make this unit that you could basically just install into an aircraft, and it will be able to learn the parameters of the aircraft, be able to adapt to it, and therefore do autonomous flying. And so we actually did test it up on a couple of drones, and it worked quite well. We also went in terms of the auto flaring and landing of the aircraft, which is a big challenge usually for aircraft and for pilots and things. And so there's there is an aspect of aviation that we have explored before. Next slide, please. In terms of transportation, we heard this morning also about transportation. Over here, we've been trying to do a remote control of a minibus taxi. We wanted to sort of see if there's, accidents, how accidents happen. Can we tip it over and let it roll over? We had these dummies with sensors inside of it that we were able to monitor the movement in the head and what whiplash there is. You'll see the steering wheel is, there's no driver over there. It's all been controlled remotely. And then it's got different autonomy systems into it that will be able to produce different maneuvers and things like that. And this has been explored even further at the moment to try and develop a system that we can use. So with this, we've been using with accident specialists to reconstruct accidents. We do the analysis of the accidents and then sort of see whether a lot of claims that people are saying, things that weren't working properly or so, did actually happen or not. And in that way, we can and analyze it and look at the evidence and present it back in the publications and to people. Next slide, please. We also had to look at medical. Top left is the respirating system that we worked on a few years ago. That was one of those things that were used for COVID. Everybody jumped onto the bandwagon for that, to be honest. And again, like we heard also this morning, 90% of these items were just stored in a hospital over there because they couldn't really be used and people didn't know how to use them, type of thing. We also looked at endoscopic probes as an example. You'll see at the bottom left over there, a soft robotic system that we developed. And that used the video clip that's shown on the top right in terms of being able to be used as an endoscopic probe, be able to identify different objects and, to assist the doctors to be able to identify where, sort of things are or points of interest might be. And so, that's been sort of a section we've been looking in terms of medical as well. There's been a few more that we've been exploring lately. But time's not going to allow us for that to go into detail. Next slide, please. Also explored prosthetics. We participated in the Sabathon 2020 Prosthetic Olympics event, as well as in 2024 event. And we looked at low-cost systems. We say low-cost, it's difficult these days to say low-cost because things are really expensive. But I mean, we did implement these prosthetic hands. And again, I think the main point I'm trying to show over here is that when you go to speak to people in other countries, they look down at South Africa. oh, South Africa's down at the bottom of the world. What do you know about anything? You can't solve any problems we've been having, and yet we've done it. And just to sort of mention over here, I mean, in 2020 event, we beat UK and Germany. We beat a few other European countries in the 2024 event. So we are able to produce good technology. And if you look on the right-hand side over there, we've been actually using machine learning algorithms to read the signals from the amputee, be able to identify what gestures they want to do or what tasks they want to do, and that way we're able to control the hand. A lot of further research is needed to go into that, though, and improvements should be made. But it is essentially a fifth industrial revolution that we are exploring, where human, robot, and artificial intelligence are coming together. Next slide, please. And we also looked at, I mean, we also heard about astronomy in the last couple of days. We're busy working with projects with SANS at the moment for remote monitoring systems. We also have been looking at this satellite tracking system, and it's still in the beginning stages that we've got, done a development, but it has been something we've been exploring. Again, a situation of we've been doing things or research that has been very similar to what other people are doing, and we probably would have had better outputs and better equipment coming out if we work together with different expertise from different people and different places that are able to come together, solve a problem, and produce something that is going to be working. And this has been something that we've been tasked to do for the last few years, just because there's the people that have been involved with it has actually retired, and that knowledge needs to be sort of transferred down to the next generation. Next slide, please. STEM is very important. Education, we heard a few times education being mentioned also the last couple of days. And over here, we had a school that had these Stimio robots. They were competing with different countries around the world. This was remote control of these robots. The Mars space or the Mars station that they had to have these robots controlled on was actually based in Switzerland. They also implemented a whole system that there would be delays in communication, as you would have when you communicate with the robot at Mars. And so it wasn't just a thing of, oh, well, I'm sending through an instruction now, and the robot's going to react immediately. And, especially if some mistake was made. This actually meant that, well, what you actually have to now implement is make sure that you think in advance. And if you give an instruction now, it might be a couple of minutes later only that the robot will perform that instruction. So, but again, it's at the school level that we've got to implement. If you look at these microbit boards as well, that's on the right-hand side, it's the same thing. We need to start educating students at the school level to be able to use the fifth industrial revolution, to be able to make use of robotics, be able to program it, and to be able to also make use of artificial intelligence that will be on a robot to be able to do the navigation. Next slide, please. Internet of Things and artificial intelligence has also been something we've heard. If you look at the car industry, you'll see there's Internet of Things often happening over there. If you look at this picture here on the left-hand side, you would also wonder, why is that one technician drilling holes in a tire? But yeah, it basically comes down to you drive in your car is able to detect the vibration, it's able to detect maybe malfunction of an item, maybe able to detect the wearing of an item, or one of the parts are worn out. And it should be able to not only notify you, well, you need to have your car serviced, but it should already place the order with the nearest service provider to be able to make sure that the part is there, so that by the time that you make the phone call to book your vehicle in, it's not a situation that you've got to now first wait for them to get the parts, and then it's some delay because it was sort of maybe not the right part or whatever. If they know exactly which vehicle it is, they know which part it is, they're able to get it very quickly. Also, if you look on the right-hand side, it's just different searching algorithms, and pick and placing algorithms have been looked at that can be explored, with artificial intelligence. I mean, to be able to know where the nearest coffee machine is, where to find a microwave just to warm up your food, especially if you're in an environment that you're not familiar with. This could be quite useful for us to have. The problem is with Internet of Things is that there's communication and there's security. And it doesn't matter what sort of robotic platform you're working on, there's always going to be some other communication aspect required over there, some other information you're going to have to get. And you need a security aspect because, I mean, if you look at some of the videos that are online these days, how much of them are AI generated videos? You can't even know if it is the real thing or not. And so, if you're busy, let's say, streaming video footage back to some control system, and you need to monitor something specifically, how do you know if that's going to be the real thing you're monitoring, or whether it's artificial intelligence aspect that you're monitoring, or whether it's somebody else that is hacked into your system of these things? Next slide, please. Okay, so the problem is that we've stagnated with research. Often I find that there's a request that we must have a robot that's able to do multiple things, like in a kitchen, must be able to prepare the food and do the lunches and do the cleaning up and do everything else, which is a great idea, but we can't necessarily do something that's able to do all that. It needs to be very focused on specific tasks. We often see that there's these pick and place robots being researched, and you sort of think, well, this has been done before. There's nothing new to it. And so I've come up with the term of a 404 robot, 404 being a link not found on your web page browser. And that's the thing, is that we've got a lot of times robotic systems that are being developed that are not practical. They're not going to help people. They're not going to solve any problems. Next slide, please. So the problem with South Africa's robotics research is, firstly, we've been sort of forced to think outside of the box. We've got load shedding, we've got water restrictions, and often it is that, with these restrictions, we've got, or it basically creates experience. And so when we have to go and suddenly find a solution to something, we're often able to think outside of the box and try and find ways to solve these problems. So we need collaborations between industry and academia. It's a win-win situation. You've got companies that are able to support the academia. Academia are able to do the research, are able to support research that the industry might not be able to do on their own capability. And it's able to support, it's able to solve problems that are in industry. Funding is a big problem at the moment. We've got our national funding organization, which some people are on the panel are funded on or funded by, but it's a very biased system where maybe artificial intelligence wouldn't be a bad thing over there, though. But it's a thing of it's basically the people that have got funding that are able to get more funding. I just had to look at the application this morning from an organization that was giving funding, and they were saying, oh, it's only for the people that are in a chair positions that are able to get these funding, but the chair positions have already got funding. So we're not able to accommodate for everybody that's performing the research. We're not able to accommodate, all the other projects and ideas that there might be to solve problems. We've got to collaborate and share resources, share equipment. I mean, I might have a piece of equipment to do a reading that you might not have, and you need it for a couple of weeks. Why do you need to go and buy a new piece of equipment for 2 weeks of tests and then you're never going to be using it again? We need to be able to share parts maybe that we've got. We need to share funds. Often it is that there's some people that have got so much funds they don't even know what to do with it, and they've got to make use of it by the end of the year before the new funding cycle. And if we work together, and we're able to fund different things, different entities, again, it will always come back to us in some or other way. It's also a great opportunity for us to support each other in applications, like not only funding, examiners. We need examiners for our postgraduate studies. We need to co-author on publications. It's crucial for us to work together and to assist each other. Even to find reviewers for conferences and stuff has been really difficult. And it's important for us to be there to support each other. We need to reunite the RobMech PRASA conference, something that we've been running since 2007. And so we need to be able to use this as a means for us to get together, for us to network, and be able to, even work together in terms of funding for the conference, in terms of doing different duties, like reviewing papers and things like that. So it's crucial for us to start working together. A lot of the problems will be only resolved once we start doing that. Next slide, please. Education as well. So I see my time is a bit over already, but I'm going to try and be as quick as possible. So in education, it's important, and we need to embrace this change. Like I mentioned, at schools, disadvantaged schools with limited equipment, if they're able to watch a video that's able to show how the equipment is working, how experiments are being performed, they've been exposed to it where they wouldn't have been able to do that before. So it's also allows us for school kids to be able to do programming and be able to have like virtual hands-on exposure. Virtual reality is something new coming in. It doesn't have to be that you have to have a virtual reality headset or so, but it could be even on a computer to see how things are working and to sort of virtually touch things. At the universities, it's also important. I've got a big fight at the moment about that, or let's say a disagreement about it at my institution, because virtual reality training is important. It's the fourth industrial revolution. That's the way that we are working. We need to do remote learning, have videos for lectures. You could even have remote practicals with a virtual reality type of thing. And I know of some institutions that are actually using the Internet of Things to allow students to log in and perform the tests and see how the equipment, what outputs the equipment is doing and stuff. Just think about it. We could have in Africa, or even in South Africa, a person that might not have the money to be able to pay for the accommodation and transport and everything at the university, but they might be able to connect virtually, maybe able to attend their lectures. Maybe they have to come 2 weeks a semester to the university to do their practicals. But we're able to then get so many more students signing up. We're able to educate more people at the same time, not necessarily increasing the workload too much, but it will allow us to have an impact on communities out there that wouldn't be able to go to universities or other institutions. Next slide, please. So in conclusion, I think the future for South Africa is that we need to start looking at open source research. We should try not to reinvent the wheel. We should try not to do parallel research. I mean, if you look at what we've done, or just in the last couple of days with the presentations, a lot of the research I've shown you now has been done also by other people. Why haven't we been working together? Why is it that we've been all starting at the bottom, basically, with a specific research topic, while another person might have done some research topic somewhere else, achieved certain level, and we could have actually built onto that. So we need to make our work available for others in terms of publications and similar things. Like I mentioned, we need to have that collaboration. We need to have that network. I think multidisciplinary is quite important for research. A lot of people are too focused on their research, and if we basically looking at solving problems within the country as well as all around the world, we need to expand our horizons. And often what we're finding is that a problem that gets brought to us that needs a solution, we often are able to have a solution because it was used in another discipline. And we're able to then bring the two disciplines together, find a solution, and help people with that. So a few key points or questions to just leave with you is what robotics research are we going to be pursuing? Or what industrial revolution research are we going to pursue? Is it going to help people? Is it going to be just theoretical? Because there's a lot of research happening at the moment that's just theoretical. It's never going to be able to be applied in real life. It's never going to be able to help anybody. And are we going to be able to adapt in this education sector, this fourth industrial or fifth industrial plus revolution? It's going to be important for us to be able to find ways to adapt and to bring that into the system. Next slide, please. And that's my final slide with different links. Should you be interested to see different, sort of contacts, different links to videos and stuff, and also, with the Robotics Association of South Africa, IEEE, and other entities that we've explored over that you've heard the last few minutes. Thank you very much, everybody.